a search in Google, you can actually limit that search to a certain website or domain area by using the site keyword. So if you do site colon here, and then you can type youtube.com, and that'll like limit your search just to YouTube in this case. And then the other thing is, if you use quotes, like I'm going to look for Hartman Automation. Okay, but I'm going to put it in quotes, which should then limit that search to only those two words together. Okay, and so if you look at this, I've been uploading, you know, some of these videos here that we've been doing, and like I say, some of them are actually some projects, and I don't know how well they're going to show through Blackboard here, but you know, so these are a couple of projects here. This one I called Dropping Marbles. I don't remember what the original title of it was, but you can see it here. And this was just one of the projects and one of the students have done, and I think maybe I pointed that out to you because we still have this little colorful tower thing sitting in the classroom up above the cabinet. So and this was a video of the project running here. So and I've got some more of these. I plan to try to get some of these uploaded later, but you know, I just thought I'd share those with you. And so I think if you were with me last week, you know, what we're going to have to do, you know, because of this virus there and everything that's going on, you know, we really can't do a project. So what I'm going to do is do a couple of labs, and then three labs, I think. We're basically going to have like 3 labs here over the next couple of weeks, and then we're going to have that extra makeup exam that I discussed. And then once we're done with that, that'll be it for the class. Okay, and so, you know, so unfortunately you won't be able to get to do your own project. However, once this thing has passed and we're back at school, if you want to do a project on the robot, you have a couple of different options. Number one, depending on what your major is, you may have like a capstone project that you need to do anyhow for, you know, before graduation. You may have a tech project class. I know definitely the electronic students have to do that. So, you know, at that time, if you want to build into as at least part of your project incorporating these robots, that's certainly an option there. So always keep that in mind. You know, if for the electronic, it's pretty easy to do. But even if you're in a different major, you know, it might be something that you can do. The other thing is, if you just kind of want to do a little project on your own, you know, come see me. We can set up open lab time and discuss it, and you can do it. There won't be any grade for it. But, you know, just if you want to, you know, spend a little more time working with these robots, you know, I'd like to make that available to you. Okay, so other than that, like I say, what I'm basically planning on doing here is for the next, I'm going to give you like 3 more labs, and I've uploaded the first one here under week 11 through 15 additional labs. Okay, so this is the first one, and actually, if you look at this, you may think, hey, I've already seen this before, because a lot of this was actually week 6 lab, but then I modified it a little bit and added a couple of things. But part of the problem here is the fact that since we're not at school, you don't have your week 6 lab to start with, so we have to rebuild it. So so that's kind of what we're going to kind of do here, and I'm going to kind of walk you through this. Like I say, I have under announcements, right? So if we come over here under announcements, I have this link right here to, this is a link to my OneDrive at Stark State that you should be able to go in here, and it's actually a directory, which is the Roboguide software. It's the 30-day, it's only good for 30 days. It's an evaluation copy. When you click on this link, I'm not sure what it's going to do here. Oh, yeah, it asks for the password, right? Yeah, so I give you the password as AIT220, okay? And so then you verify that, and I don't want to save that, okay? So anyhow, then this is an entire directory, okay? Now this thing's got 42 items in it, and so what you need to do is download this entire directory, and then in that directory is a setup.exe file, and you need to run that, and hopefully it should just install this. The thing is this directory is 2.4 gigabytes. It's really big. Okay, it's pretty much the Roboguide software. I mean, as far as I know, it's the entire Roboguide software. It's just got an 30-day evaluation license piece on it. So it's really, really big to download. So, you know, if you have the bandwidth, then, you know, download it and install it. You should be good to go. If, on the other hand, you got not very good bandwidth, then you need to let me know, and I will burn a DVD to you and get it to you. You know, just send me your address, and I'll have to mail it, snail mail, I guess, to get it to you, and get it to you that way. But it's very, very large. And of course you need Windows to run it. It won't run on a Mac, won't run on Linux. So, but any decent modern PC running Windows 7 or above, it should run fine. We used to run this on Windows 7 because we just updated, I don't know, a year and a half or whatever ago to the latest Windows 10. But so it should be anything Windows 7 or above, it should install and run on. It might run kind of slow, you know, because it is a whole virtual machine kind of thing running on your laptop or on your desktop or something. So, you know, we kind of saw that in lab. It's not the fastest thing, but it should work for these couple of labs. So if you need me to mail you something, then let me know. And I did hit record, Matt. Thank you. I don't know if you probably caught that, but okay. So anyhow, so this lab, I just kind of want to go through, and this is, I guess, is going to be kind of a review, which in a lot of ways the project is kind of like that, because a couple of the things that we had to do on the project was recreate our user frames. So it really kind of takes us back and does that. So one of the things that you have to do in the program here, this is kind of go over the instructions on the program. So we're going to start Roboguide and create our new cell named Lab Week 11 Shapes. Okay, and I just I like using version 7.7 here, and I like this robot. This is just about my favorite robot to work with here is this 2000 IB 165F. And then with this newer version of the software, now shoot, I just thought about this. You guys have version 8 of the software. That's the eval copy I have. But the version we actually have in the classroom is version 9. Version 9 automatically assigns your pointer, or it doesn't. It has a screen during the setup that asks you what you want your tool to be. I think the eval copy, if I remember right, I know it's version 8. I don't remember it asked you that. So I think you actually have to add your pointer after the fact. So I'm going to go ahead. I'm using the version we got in the classroom. And so I'm going to run that. And I'm just going to tell it no pointer. And I'm just going to kind of run through all of this with you here. And, you know, if you've got already downloaded that software and got it up and running, you can kind of just walk through with me. If not, you have to download it later. Like I say, if you're having troubles downloading it, let me know. I will burn a DVD and, you know, send me your address and I will mail it to you. And hopefully it'll be there within a few days. Fortunately, the mail system is still working, and so you know, we could go from there. But of course, you would need the DVD player to load it onto your computer. All right. If you don't have a DVD player, let me know. I might have a couple of flash drives around here. I've got others at school, but you know, I could send you a flash drive if I really needed to. All right, so anyhow, so I'm going to start Roboguide. I'm going to start a brand new copy of Roboguide because that's what you're going to have to do. So, so we're going to load up Roboguide. And remember in the classroom, we kind of had to play those games with the go into tools and options. Well, here we don't really have to. On your own PC, you should be good to go. So you just come down here and you're going to say new cell and then look at your document. Oh, not that one. Okay, so we're just going to, you know, look at our document and walk through all this setup. So we want version 7.7, handling tool 552, and robot 2000 IB 165. Okay, so you can just flip back to that as you need to, but so I never like using a generic name like they give you here, and so, you know, I'm calling this Lab Week 11 shapes, and then we're going to click next, and we're going to create a new robot. Okay. And we're going to choose version 7.7. And this is the point where I think we're going to select handling tool 552, but on version 8, I don't think they had this pointer piece over here. So for me, I'm just going to say set pointer later, or set end of arm tooling technically later, and click next again. And then I'm going to choose the robot here. And then this screen here, we're not going to add any extra axes at this point. We're not going to add any other software options here. We'll just leave it go. And check out our summary, make sure everything's okay, and select finish. And let it load there for a second. take a drink of coffee while we're waiting. Okay, or tea, or whatever your preference is, I guess. Actually, mine today's a cross. If you guys care, it's a half coffee and half this like turmeric tea. It's like got turmeric and cinnamon and ginger in it and something else. I don't know, but I use it to beef up my coffee once in a while, and it doesn't have any caffeine in the tea portion either. So, all right, so still loading here. All right, so Austin, you're saying how do you open it? Well, do you have it installed? When you download it, you download that entire directory. You have to get the get that whole directory, and then there should be a setup. Once you've got it there, you should just be able to like select your Windows key, pop up your Windows key down here, and select and just type in Robo to load it if you have it installed. Do you actually have it installed? One thing I would say, if you want to ask a question, there's that little raised hand icon at the bottom of your black window, and if you do that, it'll like chime for me. It doesn't come up in your search bar, and you ran the setup piece. So, but if you click on that hand, it just what it does is give me a little chime letting me know that you're putting something in the chat window there. So, all right, if it's not coming up in your search window, then I guess what you could do is you should be able to just come down here, and it should, I think it just shows up under Robo. Let's see, Robo should be under ours, I guess. No. We'll go find it here. I'm not sure. I don't know. If you just installed it, there, it should be under FANUC Robots. Okay. Yeah, you've got to run that setup after you download it. So you go into that directory that wherever you downloaded it at, and do that. If you don't know where you downloaded it at, when you if you used Firefox to download it, one thing you can do is click on Downloads and do a right click here and open Containing folder. Okay. The install is probably going to take a little while because it's huge. It's 2.4 gig when you got everything, so it's going to take a little while to install it. Okay, so click to open it and sends you to the file manager. Yeah, I mean you got to, and when you're in that file manager, you need to go into the directory and run the setup. I mean, it's not going to prompt you to do that. It's not a standard MSI install file that like most applications give you. And, to install in Windows, usually it's an MSI, and you download it, and it pops up and says you want to install, and you click yes, and this doesn't do that. You have to, I couldn't get it into a zip file. The thing was so huge, so I'm not quite sure what it's like when you download it. but you definitely will have to open that file manager and go in and run setup. And there's a setup exe file in there that you will have to run. Okay. So like when you download it, you should get like this Roboguide directory, or maybe it zips it as it comes down. I'm not sure, but then you need to come in there. So inside your file manager, you come in there, and there should be like 42 items there, and down at the bottom is setup.exe. Okay, it's dated, for me, it's dated November 10th, unless it changes the date. And November 10th, 2003, because this is just a setup file. You can see some of the others are newer, but this is just a setup file, and it's and run the setup file, and it should install it. But all right, so any other questions there? Okay, so Matt, you're saying it actually did when you grabbed it, it kind of tied it into a zip file. I tried to just make it a zip file myself, and it was just bulking at me, and I assumed it was so big, but okay, so yeah, so unzip it, extract it, and then under the extraction there should be a directory, and then there should be that setup. All right, so I want to go ahead and, if you guys are trying to do that, but I'm just going to kind of walk through. A lot of this is really, again, review things that I just want to remind you about, and then you can work on the lab on your own time there. So when we first open this up, so this is a brand new work cell, and you see down here the little XYZ origin thing is green at the base of our robot. Okay, and so if I double click on the robot itself, it pops over here and it tells me that the location of the robot is at the origin 00000. Okay, but because this thing is green, if I click on my robot, I might have to close that window. And I click on this robot and hold it down. And I can actually drag this guy around. See? So I can just like grab my robot, and I can, I can lay him half sideways or whatever. Okay, and get him just going all wacko here kind of thing. And so we really don't want that. So now if I double click on a robot, you look at these numbers and they're all over the place. Okay, well, the fortunate thing is that I can just come back in here and zero it back out. Okay, and hit apply, and that puts my robot right back where he should be. But then the other thing I want to do now is I'm going to click on this lock and apply that, and that's going to make this red here so that I can't accidentally move my robot. And that's pretty much true for everything that you do. Okay, is you have to, when you add a fixture in here, you need to lock it down or the thing might end up moving on you. Okay, so the other thing to note is here on my on my faceplate of my robot, I don't have a tool because I selected no tool there. And if you guys do this, I do believe it's going to not even give you the option to add the tool until after the fact because of the version of the software you had. Because I'm pretty sure, if I remember correct, it was version 9 that did that auto tool sort of thing. So here you see that the tool center point is the center of my faceplate of the robot. Okay. And so one of the first things that I kind of walk you through doing in the lab, even if you actually already added the pointer, I asked you to resize it. So we're just kind of have to do both at this point. And so I've got this pointer, and I'm going to come over here in this work cell area. Okay, and I'm going to come over to GP1, which is my robot, and I'm going to, underneath there, I'm going to hit that little plus, click on the plus, then I'm going to click on the plus under tooling, and there's end of arm tooling 1, which is UT1, which is my tool frame. So the way this virtualization software works is when you assign a tool, it is also basically putting that tool in the tool frame. So I'm going to select U tool 1. I'm going to double click on that. And before I actually go anywhere with that, I'm just going to kind of look at these, and you can see that, you know, everything's 0 here. And now I'm going to come up here to this little folder and click on that folder. And under there, you can see some various things that they provide us. They provide us some parts and some obstacles and various things that we can do. But I'm going to come here to end of arm tooling, EOAT. And under pointers, there's only one pointer to select, but I'm just going to grab this pointer. And I want my scaling of the pointer, the X and the Y is going to be a 1, but under Z, I'm going to make that a 2, which is 200%. All right, because this is a pretty big robot. And so this pointer, if you just leave it all 1s, it looks a little stubby. And so I like using a 200% and the Z. Okay. Now, the other thing, though, is my tool center point is buried underneath of that. Okay, so I need to do two things here. Number one, I need to make sure I lock it. If you do not lock that pointer location, then you can drag the pointer, and then you end up getting this pointer floating in thin air. So as you move your robot around, the pointer is moving around in thin air. So let me just show you that here. I'm just going to move it in the X direction. I'll say 100 millimeters. Or actually, I'm going to do it in the Z direction because that'll be straight up. It'll probably be easier to see. So I'm going to do it the Z direction, 100 millimeters, and hit apply. Okay. And oh yeah, it's 100 from the it's in the tool frame, right? So plus Z is away from that. So you can see under here, this is my tool center point, right? And so now I've took my pointer, and my pointer is floating out here in thin air. And now I'm going to just lock this for a moment. All right, so here's my tool. And if I try to jog my robot now, my tool is just, it's like floating. It's just floating out there 100 millimeters from the faceplate, okay? Because it's locked 100 millimeters from the faceplate, which kind of looks funny, all right? So we really don't want to do that. So I'm going to come here, unlock it. Oops. Got to click on my tool first, okay? And I'm going to unlock my tool and reset that back to 0, which ties it right back so it's bolted to the faceplate, which in reality, right, it would have to be. I'm going to lock that, but now my tool center point is still right there underneath the pointer at the center of the tool faceplate. So I'm going to come to user tool, Well, one thing I could do anyhow is come to user tool. Since I know, well, in this, I actually know the value because I've done this before. So if I know the value, I can just punch in 360. Okay. And so then what that does is that moves that tool center point then right here to the end of my tool. And remember, you can zoom in using the wheel. You can zoom in, and you know, if I get in too close, you see maybe I'm not quite on the tip of that, but you know, so you know, you can see your accuracy. So I kind of know that value. All right. But if you don't know it, we could also teach that tool, which we did in one of the other labs. Okay, so you can go back and review that. That was the frames lab. You could go back and review the tool frame lab. And I had to have you set up a point there to do that. But the other thing here is we could just, if I click on this, I can just drag the tool center point, which is this green dot here, right? And I could just grab it and shift it. Okay, but you see, as I zoom in more and more, you know, you can see, you know, it just depends on how much you want to zoom in. You can really zoom in or zoom out with this software. Okay, but 360 is pretty daggone close, and so I just like to use that because it's kind of a round number instead of being at 358, which I think is maybe a little bit closer. But all right, so so anyhow, now we've got that tool. Okay, and I've got my pointer there, and my robot is just out here because I was playing around with it and I got it all kind of jabberwockied. You know, that's a robotic technical term there, jabberwocky. So he's going all over the place. So one of the things we can do is we can force him back into position. And so, and this is kind of a nice thing with the software here is, you know, like if you come down here and you go to joint mode and you can set the joints all back to 0. Okay. And where's my, okay, and so usually I use a teach pendant for this. Where's my teach pendant? There it is. Okay. Oh, wow. Okay. I shoved it way off the screen here. Okay. So, so if we click this position button here, which this of course only exists on the in the software, not on the real robot, but we can just come in here and zero these all out and do a move to, and that just puts your robot back to the way it came from the factory, standing straight out in that mastered position. Okay. All right, so and then click at X to get back to your buttons there. All right, so anyhow, the rest of the lab, or the next part of the lab anyhow, is to come in and create some fixtures, and these fixtures just give us a reference for things to move around. And so we're just going to add some nice simple fixtures. And again, these, you know, I don't know how, but somehow these fixtures just almost defy physics, and it just, they put it in here and it's sitting on the top of the robot. Okay. So I give you, in the lab, I give you those dimensions. Once I find that browser window, there it is. Okay, so I give you the dimensions. So the first thing we're going to do is a brown box. And I don't know if you want to call that color brown or not. I think that looks a little more brown to me, but yeah, I'm not really that concerned about the colors, except for it just helps with the instructions by assigning colors. But now if we look at the lab instructions here, all right, so let me just pull these back in here. So we're going to have a brown box, 400, 800, 200, and then the box location, 1200, 400, 200. Yaw, pitch, and roll is all zeros. All right, I'm just looking to see whether anybody's put anything in the chat window here. Okay. All right, so all right, so our box position is 1200 in the X, 400 in the Y, and 200 in the Z. And then the size of the box is 400 by 800 by 200. Okay, so I apply that, and boom, now we've got this box sitting here. Okay, and I'm going to lock the box. Okay, and so here's my box. And a couple of things just to note about the box as a fixture here is they put the coordinates on the top of the fixture, in the center of the fixture. Okay, so what that means that I put the Z, the box is 200 millimeters tall. Okay, so the box is 200 millimeters tall, and I want the box sitting on the floor, right? So this gray area here with the lines is basically the floor. And so if I was to make this box have a 0 Z, then the box, you can kind of see the box as we rotate. There's the box, but it's actually under the floor, okay? Because they put they base these numbers here on the center of the top of the box, okay? I don't know why, since they do the center of the box, I don't know why they don't do the center of the box height-wise also. So they do the center for the XY, but the Z is the top of the box. So that's why these numbers are set this way. Okay, so now I've got the box sitting on top of the floor. All right, and I know this is, you know, this is pretty much all review for you, but I just want to make sure that you guys remember this. So when you're trying to set this up, when you got your software installed and running, all right. So then we're going to add another box. So we're going to add another fixture. So right click, add fixture, box. And this one I suggested to make red. Okay. And the dimensions for this one are, the size is the same, 400, 800, 200. Okay. But this one's going to be 1400 minus 400 in the Y direction and 200 in the X direction again. Okay, yaw, pitch, and roll are 0. We're going to lock it. Okay. Whoa. 400, 800, 200. All right, so yeah, that's not really where I want, because this thing's 400 wide. Make a note on your lab. Let's make, and I'll update the document here after class, but let's make this 1600. Okay, so let's make that 1600 because I want them to meet in this point right here. Okay, so they just the two corners meet. So let's make this one 1600 and lock that. Okay, so remember this needs to be red here instead of green. Okay, so you need to make sure it's locked. And then we're going to add one more fixture. We're going to add one more fixture here, which is going to be a circle or cylinder. Okay. And notice here that the cylinder is laying on, well, it's actually floating around, but it's in such a direction that, you know, if you laid it down on the floor, it would roll away on you. So here we're actually going to have to set the yaw. So we are going to set the yaw to 90 degrees. Okay, and that sets the cylinder up. And I said to make it blue. Okay, and that's a really dark blue there. Make it a little bit lighter. I'm not overly concerned about what the color is. It's just you know, when I want to talk about them, they need to have a different color. So hopefully these colors work well for you. And so let's see. So the dimensions of the cylinder. Okay, the cylinder, you know, has a diameter, and the diameter is 400. And then the length of it, which is going to be the height for us, basically, is going to be 200 millimeters. Okay. And then I've got to set my X. So my X is going to be 1400. It went the wrong way here. Why did it go backwards? And 200. These numbers don't seem right to me. I copied these from the other lab, but okay, so all right, I don't know why that seemed like it moved on me. Okay, so this is actually what I expected for the moment, because I did not, because I just changed the red box, and so it was off. So we need to add another 200, so we need to make the X here 600 for this one also. So the circle is out there, okay? And oh yeah, okay, so the 200 is because the length is 200. All right, so now if we look at this then, right, this looks pretty much like our setup before. So I just kind of wanted to make a special note here on these that, you know, the circle and the red box are touching right here, and the circle and the brown box are touching right here. Now, the diameter of this circle is 400, so that means this is this line right here where the two corners meet, right, that's y equals 0. So this over here is plus 200 in the y direction, okay? So you want to kind of just, you know, you should keep in mind what your directions and things are going to be like, okay? So now let me zoom out here to the robot, and I notice my pointer is missing, okay? My pointer is not really missing. What happened is when I was clicking around over here, I clicked on user tool 2, tool frame 2, or end of arm tooling 2, and so I switched my tooling is what happened. So if I just double click on user tool 1, or single click, I guess, single click on user tool 1, that gets me back to my pointer, okay? So my pointer didn't really disappear, but my pointer is associated with user tool frame 1, and when I was clicking over there, I ended up clicking user tool 2, and that's why it was gone. But now, one of the things that I want to do is, as I've said in class, I like to have the pointer pointing straight up and down. And if you just like come over here and click on this and try to come over here and twist it and things, it's really hard to get the thing straight up and down, okay? So what I find the best way to know that you're truly perpendicular is to take your teach pendant, I guess I made it, is to take your teach pendant there, is it there? There it goes, okay, and hit this position button. I just want to zero it back out again because I changed everything, okay? So I'm going to zero this all back out. Okay, and I'm going to do a move to, right? So now it's all perfectly straight. And then I'm going to go to J5, and at J5 I'm going to make that a 90 degree. And so now you can see that, boom, this is pointing straight down. Okay, so my pointer is pointing perfectly straight down. Okay. All right, so now that I've got that, I can make use of the software, and I can click on this plus Z and drag this straight down. Okay, but the thing is that if you you know, if you try to jog with the teach pendant, that's okay, but if you're in joint mode, then you're not going to have that thing perfectly perpendicular. Okay, so I like to kind of force it to be that 90 degrees so that we know that one is straight down there. All right, and then what we're going to do here is this is going to be my origin right here where these two boxes meet. Okay, this, and again, we can zoom in and just, you know, try to get closer and closer on here, but we want this to be where these two meet. So you see the X is, this is the X direction. Now this is our tool tip, this is our tool frame. So X is going in that direction along with the red box. Y is positive Y is going in this direction of the red box, and Z is actually going into the box. So Z is kind of going straight down into the box. All right. So this point is kind of the focal point for the lab. But what I'm asking you to do, and this is a little bit different than what you did in the previous lab, but what I'm asking you to do in this lab is to create your user frame. So we're going to go to frames. And again, part of the reason of this is, like, if you were actually doing your project, as part of the project, I would have assigned you your own user frame and tool frame, and you would have had to reteach them. All right. And so what we need to do is we need to come in here to our teach pendant. Okay. And I'm going to go to menu, setup, and under setup, I'm going to select frames. Okay, and actually you can see here it defaults to tool frame, right? So this is my tool frame, and I'm going to go into the details of this, and I see that my tool frame is 360. That's what I set. Okay, so now if we look at our lab, okay, in the lab I asked you to enter in the values of X, Y, Z, yaw, pitch, and roll for your tool frame. So this is my tool frame. So everything's zero. Everything is zero here, except for the Z, which gets a 360. Okay. And so now what I'm going to do for this lab is I'm going to create a little Blackboard assignment in lab where you can actually type in X, Y, Z, yaw, pitch, and roll into little boxes in there. Okay, so I'm going to put those in there, so you can just write them on the form for now, or just, you know, write them down on a piece of paper as you work through the lab, and I'll try to get this in there sometime tomorrow, and then you can just be able to enter those values right into Blackboard. Okay. One thing I'm going to say though, notice that, right, these are in millimeters and they have 3 decimal points. Okay, so you need to use the 3 decimal points there. So put 0.000 for your yaw, pitch, and roll, and your X and your Y, and 360.000 for your Z, because Blackboard wants those to be precise. Okay. All right, so the other thing that we need to do is to create our user frame. All right, and so the user frame here, then what we're going to do is we're going to hit previous to go back to the previous screen showing all the tool frames. We're going to select other, go to user frame, and we're going to set user frame 1. Okay, so I'm going to go ahead and hit enter here, and then I'm going to teach user frame 1. Okay, so I'm going to go to method, 3-point method, and orient origin point. What I'm going to do is take this point that I'm at right now, and that's going to be my origin. Okay, so this is my origin of my frame. So I'm just going to come over here and I'm going to do a shift record. I've recorded this point then as that origin. Okay. Now what I'm going to do, okay, is I want to teach this, and I don't know if I said this in the lab very well, but I want to teach it in the same frame as my world frame is in. So I'm going to grab the Y and just drag it actually this way, 250 millimeters. Okay, because remember, when you teach your tool frame, this tool frame, you should be 250 millimeters away for accuracy. So it could be more than that, it doesn't matter, but I just want it to be in that perfect Y direction aligned with the world frame. Now remember, what we're looking at here, Y's pointing this way, but that's the tool frame. All right, and so now what I'm going to do is I'm going to move down here, and this was my Y direction. Okay, it doesn't matter which one you teach first, but you need to make sure you record them in the correct position. So this was my plus Y direction. Now I'm going to come back up here and I'm going to do a move to get it back to that origin. And then I'm going to drag it in the plus X direction. Okay, so I'm going to drag it in the plus X direction. And I'm going to move over here and I'm going to record that. Okay, so now I want you to notice here, right, these are my numbers, and the X is 1399.7. Well, remember that this point right here is 1400, because this point, the center point of the thing was 1600, and it's 400 wide, so that means you're minus 200. So this is 1400. So the X at this point is 1400. I'm at 13.997. Okay, that's pretty daggone close. And the Z is minus 469, because remember your world frame, this is based, these numbers you're looking at here are based on the world frame. And remember that the world frame is based on this right here, where you have, I don't know if I can really draw a line here, but the world frame is from right here, where the axis 2, the horizontal of the center of axis 2, and the vertical of axis 1 meet. So right in here somewhere. Okay, I think you guys can see that here. Okay, so right in here, yeah, you can see the mouse, right? So you come straight up through the center of axis 1, and then horizontally the center of axis 2. And we're going out from here, we're going out 1400 millimeters to this point. But we also have to come down 470 down to get to this point right here, which is our origin point. And that's what these numbers are telling you. Okay. And so then if we look at the lab, okay, we look at the lab, I'm asking you to record the user frame numbers right here. And your Y should be 0, your yaw, pitch, and roll should be 0. Your X, it's okay if it's not quite perfect 1400, but it should be pretty close to 1400. And your Z should be pretty much minus 470, because that's really what it should be, minus 470. All right, so that gives us our frames. So now our frames are taught. So remember, when we're going to create a program, our tool frame should be tool frame 1, and the user frame should be user frame 1. So we come out, we arrow down here. Now to get this window, how did I get this window? Anybody remember how I got this window? I did it pretty quick, so you had to be paying attention, or you have to know, which you should know how to get that window. How do I get that little yellow window with tool frame, user frame, and jog frame on it? Somebody want to type in there? Shift chord, exactly. So press shift and then press that coordinate button. All right, and that gives me that window. Then the arrow up or down to the one you want. Select the number of the frame you want, and the window disappears, which kind of bothers me. So I always like to hit shift a chord again to view it, and then just hit previous to make it disappear. Okay. All right, so I've got my user frames and my tool frames are taught. So now we're going to create a program to go around frames, okay? Or the fixtures, I mean, that I created there. So the name of the program was LF Shapes. Okay, so I'm going to come over here and I'm going to create a program. I'm going to hit select, create, LF. Now remember, LF isn't LF, it's your initials. So last name, H for me, Hartman. And then R for first initial. And then we're going to do shapes. So S, H, A, P, E, S. Okay. Hit enter. And now if I hit detail, it will take me to the details where I could set, subtype to macro like we talked about a couple weeks ago, or, change your group mask. You could add a comment in here if you wanted, any of that kind of thing. Okay. And then when you're done, you press end, or I could have just hit edit, which would have just taken me directly to this screen, so I can start teaching these points here. All right, so now what I'm going to do, okay, is I'm going to teach it to go around the brown box. Okay, so if we look at the instructions in the lab, we're going to teach it to go around the brown box in a clockwise manner. And then we're going to teach it to go around the red box counterclockwise. Then we're going to go around the circle clockwise. And then we're going to go around the circle counterclockwise. Now, I'm not going to do this all for you today, but I am going to at least do the first part, because I want to make a point about the points and where they're going to be. So I should be starting at the origin. Okay. Actually, if you read the instructions, make sure you read all the instructions of the lab. One of them say where's it at here? The program should start and finish at a home position above the box. Okay. So what I'm saying here is the fact that I'm going to take this and I'm going to move it back right here to where these two boxes touch. Okay, so right here where these two boxes touch. Now when you look at that, make sure you look at it from all directions. Okay, so that it's perfectly lined up. And then remember, if you want to, you can add your you can come to your window and add your 3D panes over here on the right hand side. Okay, if you want to, just to kind of know that you've got the right spot. Okay, now remember that, I mean, this pointer isn't quite touching exactly, but I'm zoomed way in right now too. So it's a millimeter or two off, but that's okay for this. But this is my starting point of the box. But my home position is supposed to be above that. So what I'm going to do is I'm going to record a couple points here. Okay. And then this first point, point 1, should be up here. So now what I'm going to do is I'm going to come up here and I'm going to touch this up to be point 1. So this is point 1. Then I'm going to come straight down here to point 2 at the box. And I'm going to go clockwise as you're looking at it above. Okay, so here as we're looking at it above, we want to be going clockwise, which means I need to go back to this corner here as my third point in the program. Okay, so, you know, if you want to, you can drag. That's one thing nice about this software. Is that you can just, you know, come along here and just drag this, okay, to that point. And then I'm going to add that point, shift point, okay. And then, you know, and then we can drag in the Y direction. Okay, so we can drag in the Y direction, do a shift point. And then we can drag back in the plus X direction again. Okay, do a shift point, do shift point again. Now this point, okay, remember we can come in and label these. So I'm just going to label this one as home. I'm going to use a keyboard because it's much faster. So I'm going to label that one home. And I'm going to label this one origin. Okay, and so now down here I added both points 5 and 6 are right here at this, but I really need point 6 to be back at the origin. So it really shouldn't be point 6, it just should be point 2 again. So there's my boxes, or my points to go around the brown box. Okay. And so now I'm just going to go ahead and forward through the program. So here we are, we're starting out somewhere up above the box. I don't know if I gave you, make sure you read the instructions. It should be a, you know, some specific height here above the box. All right, and so then we're going to go forward down to the box, right there where the two boxes touch. Then we're going to go forward over here to point 3, forward over to point 4, over to point 5, over to point 2 again, and then we're gonna, the next instructions are to go around the red box and then go around the circle a couple times, and then we're going to return to the home. All right, so you know, so there I just stepped through it. If I come over, take step off, and come over here and hit play, I can simulate this much of the program. And you know, always pops that up the first time you run through it. But okay, so there it goes. Okay, and so notice I did not give you instructions here as far as speed or termination or anything like that at this point. So I just took the default, which was 100% speed at fine termination. But they're joint movements, right? So they're stopping at those points that I taught. They're actually stopping at those points, but to go from one point to the other, that's not necessarily a perfectly straight line, or it's not a straight line, really. It's definitely not. So, but that's okay at this point because I didn't specify in the lab, hey, this needs to be linear or anything like that. Okay. All right. So, but this is the first part of this first program here. But what I want to point out is remember that we're doing the user frame. We're in user frame 1. So watch when I look at the origin. What value of X, Y, and Z do you expect to see here if I look at this position? Okay. So if I click on the position here, right, X, Y, and Z are all 0. Now, you might want to argue with me that X is 0.2, but it's pretty daggone close to 0, right? And so then, if we look at 0.3, right, 0.3 is minus 400 in the X and 0 and 0. All right, so is there any questions about that? But you see, remember, this is tied to the user frame. So the Z position is 0 because it's actually 470 below the world frame Z, but we tied that origin to be our reference point. So now all these points are in reference to that. And it's 180 degree because that's the yaw. But the other ones, you know, so your yaw should always be minus 180. Your pitch and your roll should be that, you know, whatever there. But, you know, those values should be there. Okay, so now the other issue here is, though, that we need to load this into Blackboard, because part of your assignment is you're going to have to upload this into Blackboard so that I can see that you've done it. Okay, so let's take a look here. The name of this, remember, is HR Shapes. So now I'm just going to pop over to Window Manager, okay, or File Explorer, or whatever you want to call this program here. And I'm going to come here to my U drive. So I'm going to come down to local disk, C drive. I'm sorry, I said U drive. I'm thinking I'm at school. And I'm going to go to users. Okay, and it should be under my user here, but I'm not 100% sure. I'm not sure where they put this. So I'm going to use the search, and I'm going to search for HR Shapes. Okay. And I think we can get to it without saving it, but I can't remember for sure. So let's see if it can find it here on the C drive. Time for a coffee break while we wait. All right, I can't remember if you know, we talked about files. If you remember, I forget which chapter that was, but we talked about files in chapter, was it 7? Yeah, chapter 7, and we talked about the files. And we talked about like really everything is stored on the memory device, which is the built-in SRAM of the robot. And I'm not sure whether we'll have direct access to that. I can't remember. But if not, what we'll do is we'll go to our teach pendant and we'll save this, which is, so it's almost done searching here. I'm searching the entire drive because I don't know where they put it. I don't, you know, it's one of the things, there's so many files and they bury it down in there. Well, while that's finishing, I actually could have looked if I would have thought, if we would have went to this tools, I could have looked and see where they put it. So it's under C:users 205 documents, my work cells. So that's where it should be. Okay. I did not remember that, but I just remembered I could have looked. Doesn't look like Windows is finding it here, but I just want to wait it out and see if it can actually find it, because I think what we have to do, I can't remember. I think it should be visible just as it is, and we can just go grab that file. But they haven't found it yet. Maybe they're just getting to the users directory. All right, so just a reminder, right? I'm looking for HR shapes. Looks like it's done, but it's still running here. Well, let's see. Okay, so it's actually under documents. So we don't, I mean, we could go to C drive, users, C205 user. That's the user I've got on this laptop here. And then it said work cells. Maybe I didn't, I don't know. I shouldn't have had to save it, but let me just come over here and save it. Restore cell save point. So, oh no, that's restore. File, save. Okay, so I'm just going to hit save. I'm not sure if maybe it wasn't saved. Maybe that's why it wasn't finding it here, because it should be, according to the thing, it should be under documents, and then under documents I should have my work cells. Okay, so I mean, you should be able to find it from C, users, and then documents are hidden if you come this way. I don't know why they do that. See, or no, it's not hidden. It's just, I was looking for a folder icon. That's it. Document, they give it a fancy icon. That's it. So if we come under my work cells, okay, remember I named this Lab Week 11 Shapes. So there's a directory there, and that directory is this entire virtual machine of the robot. Okay, and so so then now if we come and search for this HR shapes again. Okay, see, now it's finding it. I think I didn't save it because it should have found it under there on here. But so yeah, if you look at these locations where they find this, oops. Stop. Okay, so here is this file, hrshapes.tp. Remember, it's a teach pendant program. And so that's why it says hrshapes.tp. Now there's a copy here It's not showing the, if I go to properties, I think, yeah. So this one is my work autosave robot 1. And this one is that save point that I did. Okay, save points. See, it says save points there. So when you do these save points, if you want to make a change, it's something nice with the software. I don't think I talked about it in the classroom. But when you do click on a save point, and then you can go make all kinds of changes, and then you can go back to that save point if you don't like your changes. All right, so you kind of have to watch here because you know, if you save your things, you may have various copies of this exact same file, and they'll be different if you made changes to them between your save points. So what you want to do is, you know, look at this file and make sure it's got the latest date and time on it. Okay, and then what you're going to have to do is take this file and upload this into Blackboard. Okay, so so I've got this file here now that I know where it's at. Okay, and you can also do like the open file location, all right, and see this entire path. This is why I don't remember where the thing's at. Look at that path. Okay, so this is the save point one here, but right now they're both exactly the same. But make sure you get, you know, if you got multiple copies of them through save points, make sure you upload the newest. Okay, and so then what we're going to do is you're going to have to upload this into Blackboard. So I just want to see, I haven't created the assignment for you in Blackboard for you to actually upload this file yet. So I'm going to go to another class where I know I've got an assignment in this AC class. They're supposed to upload some files here, so I just want to upload it and make sure Blackboard will allow it, because I've never tested this before, because we've never had to do this online before, so I never had to. So I'm going to go here to my new test, I think. Oh, that was an announcement. Course calendar here. Let me. It's just running slow. It won't take me there. Since I'm an instructor, my setup's a little bit different here. Whoop, shoot. Was that it? Yeah, this is it. Okay. Week 10 AC power. All right, so what I'm going to do here is I'm just going to try to upload this and make sure this works and show you here. So I'm going to come down here where there's an assignment to upload a file. I'm going to browse my computer. All right, and I know it was under Documents, My Work Cells, Lab11, and then under Lab11 there was Robot 1, which is actually your working. Hang here, I think it was Robot 1. Okay, well, the one was save points. I know it was under save points. Maybe the other was under save points too. I didn't look at it that close, but oh, it was auto save. That was it. Auto save. So it's save points, auto save, robot 1. Okay, and then under robot 1, you just go under. Let's see. Search this HR shapes here. And select it. Okay. All right, so then I'm going to save and submit this attempt. Okay, I didn't answer any other questions, so that's why it's squawking at me there. But I just wanted to make sure that this thing would open. All right, so there is that teach pendant file. And so you should be able to upload it in Blackboard okay. All right, so that's what I'm going to have you do for these programs. Okay, since we've got to do it online like this, I'm going to have you actually just upload them on there. So again, how did we get to that? I went to Documents, My Work Cells, the Lab, go to Save Points, and then there should be an autosave. Autosave, you know, if it should always have, you know, the most recent during the autosave, so it should be fairly recent in there. And then is it here? HR. Oh, it's just right under autosave robot 1. That's where it was. I just didn't scroll down to look for it. So right there it is. Okay, so this PC, Documents, My Work Cells, Lab Work, you know, week 11 shapes, which is what you should have named it, Save Points, Autosave, Robot 1, and then you just scroll down until you find the TP file. That's your program. So I'm going to have you like create several different programs, and when you create those, this is where you should find them. Okay? And then from there, I can grab those, download those back off of Blackboard and put them in mine and see if they run correctly. All right, so that's kind of what that's the theory anyhow. So we'll test that for this lab, and if it doesn't work well, then I guess I'll have to try something else. But that's how we're going to upload your program so I can verify your work. Okay. No, Austin, you do not have to fill out the actual lab. I'll have the information I want. I'm going to put into Blackboard, and you'll have to put it in Blackboard. All right, Ted, you're asking, does it create the file on the drive before you save it? It does. It's in this autosave. It does an autosave. Okay, so the file should have been there. If I would have looked in the right spot in the first place, I should have found it under autosave. There, I think, I don't know how often autosave runs. I imagine it's in a setting somewhere. But when it does an autosave, it's going to save all these files. Okay, so like the other thing that it's going to save is your frames. So if you look under here, I'll probably have you upload this file here too, which is called sysframe, system variables. These are your frames. Okay. So if you go to sysframe, this is actually your file of frames. And so I can actually take your frame file, stick it into mine, and I'll have your frames so I can see what your frames are. Okay. And the same for your macros. I'm going to ask you to configure your macros. Okay, part of this, if you read through the rest of the lab, is you're going to create a couple macros. I can upload your macro configuration. So I'm going to have you, to do that, this will be the file that you've got to give me, the sysmacro.sv. And so I'll put that in instructions in the Blackboard piece. And the stuff I asked for in Blackboard, that's what you need to give me. So no, the lab paper I gave you is your instructions to do the lab so that you guys can be working on it. And you do kind of have to record them, but you don't have to submit it, because some of you may not have the ability to scan it in or to take a picture of it. And honestly, a lot of times when people take pictures of stuff, it's practically unreadable anyhow. So I'm not going to ask you to submit the lab paper. I'm going to put more of a assignment in Blackboard where I'll have either, depending on what I'm going to do, they might be fill in the blanks, or they might be radio button, multiple choice kind of things, and you select the one that fits. Okay. But it takes me a little while to get them in there, and I didn't. My power was out all day yesterday, so I wasn't able to do anything yesterday. So I'll get those in later this week, as long as I still have power and internet. My internet was out this morning too, so rough times, right? Okay, so is there any other questions on there? Okay, as always, as you're working through the lab, email me and let me know if you need to if you need to call me, then call me. My telephone, let me just put it here for you again, 330-494-6170, extension 4125. Okay, this is actually the school number, and you can call and leave a message, and that message will be forwarded to me. And then, let me know your telephone number if you need me to call you back. Okay, I would give you my home number. I'll give it to you now. I don't care. The only catch is I don't normally answer it because I get so much, which I'm sure most of you get. I get so much junk. I don't typically answer it, so that's why call me and leave me a voicemail. 735-2652. Okay, but I'll only answer it if I am expecting you to call. So hello. Yeah, so that's my home number. So if you see me calling from that, if you're expecting a call from me, that's most likely the number I'm going to be calling from. So maybe to answer it. Okay.